Assalamu alaikum. The final two topics we want to review are beams and columns. Beams. Beams fail either in local buckling or lateral torsional buckling. Local buckling, we divided the section into three: compact, non-compact, cylinder. In beams, we like the sections to be compact. Use compact sections. Otherwise, you have to calculate its capacity in the same way that we are going to learn how to calculate its capacity under lateral torsional buckling. So here is local. If we speak about lateral torsional buckling, then we are saying about bracing of the compression flange. This is the compression flange. If we manage to brace this using studs or another means, then we prevent lateral torsional buckling. In that case, Mn will be equal to Mb, where Mb is the plastic moment capacity, which is equal Zx5. This is in case that L between braces is less or equal to Lp. Now Lp, we have an equation that can be applied easily. It's 1.76 Ry square root of E over Fy. The other limitation, if we have the length that does not permit total yielding, I'm going to draw the same curve that we draw for compact. This is, we said, compact. In the same meaning, here we have L less than what? Lp. This curve here, we said non-compact. It reaches what? Reaches a field. By the same token, we say that L equal Lr. L equal what? Lr. If at any point we reach a field, then L equal Lr, and Mr will be equal to 0.7 a field multiplied by Sx. Notice here we have two losses. One loss concerning, instead of approaching a field, we are approaching only what? 0.7 a field. If it is going to go into compact and L is less than Lp, then residual stresses starts to distribute themselves from compression to tension until they are all under a field. Because residual stresses, in parts they are tension, and in parts they are what? They are compression. Thus, if a field reaches here, it starts to spread around until all the section will be in what? In a field. So we have the first loss between a field to 0.7 a field, and the other loss between Zx and Sx, which is the shape factor. We said that shape factor Zx over Sx, which is the shape factor for rectangle, what's its value? Rectangle 1.5. It is more than 1. For an I section, it is almost 1.1. It is only 10% increase almost. So for an I section, it is 1.1, 1.15. For a rectangle, it is 1.5. And here, we should avoid L being larger than what? Lr. Avoid. Now, between Lp and Lr, we can apply an interpolation equation where Mn equal Mp minus Mp minus Mr over L R minus LB multiplied by L between braces minus LB. So we already said how to calculate MR, how to calculate MP, and this is the value of MN. This value of MN has been calculated on the base that we have the worst condition. And the worst condition is that we have a bending moment, M, uniform over the whole cross-section of the beam. Now, if we have a case other than this, then this Mn should be multiplied by a factor Cb. So Mn equals Cb multiplied by this Mn. This Mn, I mean by this. Now we have an equation for Cb. Let me remind you with this equation. Cb equal 12.5, I think M maximum, divided by 2.5 M maximum plus 3 MA plus 4 MB plus 3 MC. And this equation should be less or equal to what? What is the largest value of Mn? MP. Notice in columns we said that the largest value is a field as a stress. In bending moment, the largest value of Mn is MP. Any questions? These are the main ideas concerning design of beam. We gave you tables for LR and LB if we have A50. In case we have A36, and today I will solve a problem A36, it is easy for A36 to calculate LB. Very easy to calculate LB. However, LR, we have a long equation for calculation of LR. That's why in this lecture, I will give you LR and LB for an A36. You can verify it if you like at home. In the future, I will try to provide students also with tables of LR and LB for A36. Any questions concerning beam? Beam columns, you are combining beams with what? With columns. And let me remind you that we have many interaction curves. And we decided to put an interaction curve which represent a lower bound, and it came something like this. And the equation for this curve was F B ultimate divided by phi C Bn is greater than 0.2, then B ultimate divided by phi C Bn plus 8 divided by 9 M ultimate X of divided by phi B MNX plus M ultimate Y divided by phi B MNY less or equal to 1. And the other case, if B ultimate over phi Bn, phi C Bn is less than 0.2, then the equation becomes B ultimate divided by 2 phi C Bn plus M ultimate X divided by phi B MNX plus M ultimate Y divided by phi B MNY less or equal to 1. Notice, to solve any beam column problem, first we should calculate phi CBN, the compression capacity of what? Of the beam column. And if the compression capacity is greater than 0.2, B ultimate over this, then we have this equation. If it is less than 0.2, we have this equation. My advice to you, for sure you will have a beam column in the final. Now my advice to you is you start dealing with it as a compression member. And then write this equation. Once this equation is written, this term is already calculated. Now we are left with these terms. MNX has to deal with local buckling and lateral torsional buckling. So you have to calculate it from local buckling, and MNY has to deal only with what? With local buckling. Only local buckling. Why? Because when the member is like this, it can go like this in lateral torsional buckling. But when the member is like this, when you put an I section like this, it will never go into what? Lateral torsional buckling. Many students, unfortunately, we bring a question that the bending moment is around the y-axis, and he start doing calculations of lateral torsional buckling. You are wasting your time. So this and this already known. M ultimate x and M ultimate y, if you got a braced structure, then they have to be magnified according to member B delta. And member B delta is member B delta for braced. It is equal beta 1 equal Cm divided by 1 minus B ultimate divided by BE. B ultimate divided by BE. Now Cm, you got tables for it, and you got this equation, which is 0.6 minus 0.4 M1 divided by M2, where M2 is the larger bending moment and M1 is the smaller bending moment. And this ratio is negative for single curvature and positive for what? Double curvature. The reason, if we have this and we got this single curvature, and this is M and this is M, for sure these two bending moment will give you a bending moment diagram of this shape in the compression side. Now this bending moment will cause deflection of this order, and for sure this axial load B is making an additional B delta, which will make the moment inside the member what? Larger. That's why it will be for an equal M1 which is producing single curvature. This will be negative, and 0.6 minus 0.4 will be 1. 1 divided by 1 minus any term will be greater than 1. Now, for unbraced structures, we have M ultimate, whether x or y equal beta 1 M, no translation, plus beta 2 M lateral translation. And beta 2 is either calculated from 1 over 1 minus summation of B ultimate over summation of BE, or beta 2 equal 1 divided by 1 minus the other term that I already explained to you before. Let me see if I'm writing it here. I'm not writing it here. You got here some, I think, of H ultimate delta not H over H, and I think here you got RH summation of B, something like this. I don't want to write it. I don't memorize it. So you got two equations. You can use either this or the other equation to calculate beta 2. If you have a question in the exam, yes. Still okay.
Thank you.
More?
Thank you.
These are the main ideas that cover beams and beam columns. Let us take an example. Any questions? Now, the example we want to take is a beam column of this shape. Now, it is 4.5 meter long. It has an axial load of 1,800 kilonewton and a bending moment 70 kilonewton meter. And it is made of W12 by 120. W12 by 120. And beam column. This is a beam column for sure. We have a compression load and a bending moment, and you are asked to verify whether this column is safe or not. This is we call evaluation. I noticed that many students do not like to do projects of evaluation. Whereas while you are students, you like your question to be what? Evaluation. A section that is already there and you want to say whether it is safe or not. You don't like to do a design. In the 5th year project, I noticed that all students who are going to do project, they like to do design, not evaluation. So I cannot understand it. Let us go through this problem. Nowadays, students choose their own project. You don't impose projects on students. They choose their own project to work with. What is the first step we said? Phi CBN. We calculate the compression capacity of the member. To calculate the compression capacity of the member, what should we do? Find. Yes, to find F critical, what we should do? KL over R. Now KL over R, we got KL over R in the X, KL over R in the Y. Now KL over R in the X, we have got 1 multiplied by 4,500. And if we took R from tables, then we will find that Rx equal 140 millimeter. This provides us with 32.1. And here KL over RY1 multiplied by 4,500 divided by 79.4. This will provide us with a value 56.6. Which value governs? 56.6. This value we get phi F critical equal 190 megapascal, and also phi BN, if you multiply it by the area, will be equal to 4,332 students are not getting their chances in companies because they are weak in English. I think if you are weak in English, you are weak in Arabic. You should be strong in both. Nowadays, since the language of science is English, I want you to know English, and I want you to know English well. Try. You will find it difficult the first time, the second time, but after that it will be what? Easy. Try. I will stop until you try to speak in English. Don't think in Arabic and translate. Speak in English.
You choose the larger value of KL over R, X, Y?
Yes, the larger value.
You choose the minimum value?
No?
No.
Here it is. This is 32.1. And this is 56.6. Okay?
The dot not clear.
Okay, the dot is not clear. It seems that lecturing in English brings more fun to the lecture, so this is one of its advantages. Okay. From the start, I told you that next semester, I think it will be imposed on all lecturers to be in English, because we don't like to hear any talking that hurts the capacity of our students. Okay, now, if we want to see, to calculate B ultimate over phi c Bn, we have B ultimate in the question 1,800. Divide 1,800 divided by 4,332. It will be 1.043.
Okay, thanks.
Thank you very much. It's illogical. It should be what? Less than what? Less than 1. So if you make this division, you will find that it is 0.41, and 0.41 is greater than what? 0.2. If it is greater than 0.2, we go back to the equation. This is the equation if it is greater than 0.2. Now, let me simplify the equation. When we draw the beam column, the bending moment was in this direction. Is it around X or Y axis? If we draw the beam column like this,
Y axis.
Exactly.
this, the cross section is like this. If we draw it like this, the cross section is like this. Now, in order not to make a mistake, take this to be X, take this to be Y, then the bending moment will be in what? In the Z direction. This Y for this member, this X for this member is like this. This X for this member is like this. The Z direction will be like this. This is XZ. For this member, this will be the X and this will be the Z. So this member we have bending about major axis, and this member we have bending about what? Minor axis. These equations are written for this to be X and for this to be Y. So Z in this axis, Z in this axis corresponds to what?
Y.
Z in this axis corresponds to what?
X.
X. So this problem, I'm speaking about bending in the X direction. This term cancels out. In the exam, it is very important, first of all, to see which terms cancel out. You don't bother about them. You don't start calculating M and Y or M ultimate Y, because it's already what? Out of the picture. So we go to this equation, and we already calculated 0.41. So we are left with plus M ultimate X over phi B MNX less or equal to 1.
8/9.
Thank you. Do we have a brazed or unbrazed structure here? Brazed. If it is brazed, then we have beta 1 equals Cm over 1 minus B ultimate divided by what? BE, but here BE what? BX. What is the value of Cm? 1. Y1, we got what?
Moment is
Equal moment in the same direction. Divided by 1 minus, what is B ultimate? 1,000.
800.
Here notice that this BE is in the same direction of bending, which is what? So if I want to calculate BEX, it will be pi squared EA divided by KL over R of what? Of X. divided by K L over R of X all squared. If you calculate it, it will be 4,306.77. Put it here, 43,677. You get up with 1.043. So if we want to apply this equation, we will get 0.41 plus 8 over 9. What is M ultimate X? It is 1.043 multiplied by 70. This will provide us with a value 73 divided by phi b mnx, which we still, up till now, we didn't calculate. Now, the material for this is A36. For an A36, we find out that we got LB equal 3.9 meter, LR equal 22.7 meter. So the 4.5, which is in between, need what? Interpolation. If you calculate MP, you will find that MP equals 762, MB equals 762, and MR equal 467. From these two, you can find out that phi b mn will be equal to 677, which will be 0.501 less than 1. Okay. Notice I left some few steps for you to be done. Here we have MB, you have to calculate ZX multiplied by a field, which is 250 to get the 762, and MR it is 0.7, a field which is 250 multiplied by SX to get this value.
So, how you find the MB?
MB? In details, MB equal ZX multiplied by a field, and we are speaking about A36. So if you want the details of it, it will be 3048 multiplied by 250, which is a field. By changing the units divided by 10 to the power 3, this will provide you 762 kilonewton meter. This value ZX, you will find it multiplied by 10 to the 6, and this is multiplied by 10 to the 6, and to find kilonewton meter, you have to make some changes from Newton millimeter to kilonewton meter. I think this is multiplied by 10 to the power 3, and this should be multiplied by 10 to the power 6. So if you take this by this, you get 762. Concerning MR, it is 0.7, a field which is 250, by multiplied by SX, which you will find it to be 2.67 into 10 to the power 6 divided by 10 to the power 6. To change it into kilonewton meter, it will be 467 kilonewton meter. Notice I am doing a review for you, so I leave a few details for you to do it at home. Let us solve this using SAP and remind you how to use SAP. Here it is kilonewton meter. File, new model. You can take it as a beam and change it to beam column. If we take it as a beam, we got one span of length 4.5. The beam we imported from I-flange section 8 Pro oven. It is, we set W12 by 120. Okay. Now the F yield, we want to change it to A36 by putting the yield stress to 50 exponential 3. Now if we want to put the bending moments, then we said that here we have assign joint loads, forces. We make it on the dead and we put the dead equal to 0. We have minus 1,800 kilonewton. And notice that the bending moment at this end, to be in this direction, it is in the negative y direction. So we said minus 70. This is okay. In the other side here, we put assign joint loads, forces, and here it is 0, but at this end it is plus 70. Look at it in 3D. You will find that bending moment like this, bending moment like this, produce uniform bending moment. We can return to XZ, close this, and do analysis and design. Before doing analysis and design, let us remove the dead load. We don't want the dead load to be included in the calculations. Now we have a beam column. We can run it. By running it, go to do the design, we change to our code. Let's do it. Where is the mistake? We find that the ratio, instead of 0.501, it comes to be 0.71. We want to see where our problem is. Let us look at phi B and C. What is phi B and C? Our calculation, what is phi B and C? It is 4332, which is right. Okay. And our capacity by phi yn was 678, which is also right. But the ultimate bending moment, if you look at it, it's what?
90.
What happens? The error is so obvious and you don't notice it. What is our bending moment? The ultimate bending moment is how much? 70. Now he's calculating it what? 98. Why? Because here we should have put define load combinations, define a load combination. Let me cancel these. When we go and define load combinations,
Ultimately, from did
we don't define these.
from did
We said add a new load combination, and we remain the dead load factor equal what?
1.
1, add, that's it.
Okay.
Okay. And okay. We do analysis. And in design, we go and we say that select design combination. We need combination 1 to be added. We don't want any other combination. We say okay. We do the design. And now we get the same value we got, which is 0.507, and now the details are the same of what we had, but now M ultimate, the ultimate bending moment is 70, not 90. What I wanted you to know is that when using SAP, I have this calculation and I have the SAP output.
Very fine.
One eye on this and one eye on a SAP output. If the values are the same, I'm comfortable. If the values are different, the error is either in using SAP or in using what? My calculations. Here, it was easy for me to see that the error was in using what? SAP. It is not that all the time that easy. I never feel confident of solving any problem by looking through one eye only. This is my whole advice to you, to teach you how to think. Means that never solve any problem using only one way. You should at least have 2 ways, and the third is much better, affirm, to be affirmed. When you do the design many times, I tell you that this column is IBE 200. You tell me no, it's not. It will never be like this. Because by your sense, you know that this column should be IBE 400. In reinforced concrete, we did many designs. If I tell you that the slab this is 12 centimeter thick, you will come on. It's never 12 centimeter thick for such a span. So this feeling comes to support both eyes. It does not substitute any of them, but it is a support of what? Of both eyes. Many failures are occurring nowadays in the whole world because personal computers started to spread from 1980 and above. By spreading personal computers, engineers like to relax and only do their designs using what? Personal computers without verification. And by the time we found that many failures are occurring, the last failure, which happens last year, was due to the fact that the dead load was not included. The designer, by some way, in his program, put 0 in the dead load. No, the dead load, the structure. The dead load of the structure was not included, and he did the design. And once the collapse occurred, it is not a collapse due to earthquake. It is a collapse due to gravity. They returned to the calculations, and they found out that the dead load was missing. I speak these to you because I saw many engineers in the field. They only use SAP, and they provided us with data that is completely illogical. A few days ago, someone told me, I've got a 5-meter retaining wall. Do you think 20 centimeter is enough to carry it? Retaining wall. What do you think? It is cantilever. What is the depth in your feeling?
1.3.
The depth. Height divided by what? By 7 or by 10, by 8, by 7. When we taught you cantilevers, we said that the depth in beams L divided by 8. In cantilever retaining walls, by preliminary design, we told you it is L divided by 7 instead of L divided by 8. Now, when we say 5 meter divided by 10, it is 50. Divided by 8, it is 60 and more. So when he tells you, let us do it 10 centimeter, you find how far our feeling in practice from where it should be. If a student tell me, let us make it 20 centimeter, I need only to remind him about the rule of L/8 so that he will draw it down, and he said, no, it doesn't work. We should go into what? L/7 and larger. But when you hear it from an engineer, hearing is something, is one side. Dr. Sami Hijawi showed me pictures of retaining wall, more than 4 meter height, 20 centimeter, and it is going in all directions. 20 centimeter going into all directions. Just they put the fill and the wall. It didn't collapse, but it went what? Around. When it went around, they need now to take it out and to take all the filling and start doing it once again. I hope by this course you got a sound theoretical background to build on it your engineering sense. One of the students who wanted to do a project was thinking of a shell, and he said, well, if we want to do a shell, we will have problem of connections at the top. Such a speech was between him and Ustaz Imad, and Ustaz Imad told me, well, now the idea of connections is in the mind of our students. We put connections all the time at the end. The student graduate, and he said, I cannot design connections. You are the first students to graduate by starting with connections, and I feel that all of you feel somehow you can design connections. I am not saying that you are 100%, but you don't fear of designing connections. It seems to me that before, when we put connections at the end, students graduated feeling that they never design any connection, and also they don't understand how to design connections. If you find any idea that will make this course better course in the future, do not hesitate either to say it in front of me, to put it on a paper underneath my door, or by any other means. Such an idea will help us improve our teaching skills for your brothers who are going to take steel structure next semester. If you find that you need an extra exam, an extra project, to cancel the project, to put the lectures in a different form, do not hesitate to provide us with an idea of yours. Good luck.